ECM process characteristics, material removal rate, accuracy, surface finish. Material removal rate (MRR). The MRR depends chiefly on feed rates. The feed rate determines the current passed between the work and the tool. As the tool approaches the work, the length of the conductive current path decreases and the magnitude of current increases. This lessening of the gap and increase in the conductivity goes until the current is just sufficient to remove the metal at a rate corresponding to the rate of tool advance. The overall machining rate is governed by Faraday's law of electrolysis, which states the quantitative unit of electricity called Faraday, which is the amount of electricity that reduces 1 gram equilibrium weight of a substance at the cathode and oxidizes 1 gram of equivalent weight of a substance at the anode. Accuracy. There are number of factors which govern the accuracy of the parts produced by ECM. The major ones are machining voltage, feed rate of electrode tool, temperature of electrolyte, concentration of electrolyte. Under ideal conditions with properly designed tooling, ECM is capable of holding tolerances of the order of plus or minus 0.02 mm less. In general, tolerance can be maintained on a process basis in the region of plus or minus 0.02 to minus 0.04 mm. ECM results in the internal radii greater than 0.2 mm and external radii of the order of 0.05 mm. Surface finish. In ECM, the surface finish is of the order of 0.2 to 0.8 micron meter depending on the work material and the electrolyte used, and no burrs or sharp edges are left on the workpiece. There are some factors on which the surface finish depends are feed rate, voltage, electrolyte concentration, electrolyte temperature. Process capabilities. Under ideal conditions, ECM is capable of producing approximately plus or minus 0.12 mm. Depending upon the tool design being used, taper can be held at 0.25 mm per minute. The side of the tool may produce surface finish as rough as 5 micron because of low current density using hollow tubing. As the ECM tool, the holes as small as 0.76 mm in diameter can be drilled length diameter ratios up to 20:1. Advantages. The process is capable of machining metals and alloys irrespective of their strength and hardness. It produces very good surface finish. Deep holes can be made by this process. High surface finish 0.5 micron can be achieved by ECM process. No burr is formed on the workpiece. Workpiece materials do not undergo metallurgical changes and are free from surface and subsurface cracks. Disadvantages. The non-conductive materials cannot be machined. Tooling costs are relatively high. Corrosion and rust of the ECM process can be hazardous. The process is not economical for small quantity production of dies and workpiece. Space and floor area requirement are also higher. Applications. ECM is one of the most highly developed. It appears to have greatest potential for versatility and is now being commercially utilized. The process can handle a very large variety of materials limited only by their electrochemical properties and not their strength. Material removal rate (MRR) are high, especially of high strength, difficult to machine alloys developed for the needs of the space age. Fragile parts which are otherwise not easily machinable can be shaped by ECM. Some specific applications of ECM are facing and turning complex 3D surfaces, multiple hole drilling, trepanning, broaching, profiling and old shape contouring, die sinking, particularly deep narrow slots and holes, deburring, grinding and honing.